Hello, my name is Nico Caracassis, and this is the What Stories Do Data Tell class project. So, for this class project, I used a dataset called Sleep Health Dataset. Of course, you can upload any other dataset you want, but a lot of the things I did for this Streamlit project are require some of the default columns, for example, the hypothesis and the machine learning models. Now, the data has 32 columns and 100,000 rows. Here, I put some of the data sets, such as the raw data. I put down some descriptive statistics of the raw data, mainly to visualize and see if I could find any weird outliers or connections. So from the outliers, I was able to find that there were indeed a lot of outliers here and there. For example, the alcohol units before bed, there were a lot of outliers there. Same for screen time before bed and caffeine before bed, which in all honesty I didn't expect. There's also a lot of outliers in stress score. But yeah, afterwards I decided to remove such outliers by using only columns that have decimal numbers. So all of these columns only have decimal numbers, and they have their uh, outliers removed, which lowered the amount of rows down to 76,000. Now, I wanted to visualize this, and so I decided to use a correlation matrix to see if I could find some correlations. Now, here are different tabs with a multitude of different kinds of visualizations. So the redder something gets, the stronger of positive correlation it has with another factor, right? So for example, the amount of sleep hours has a strong positive correlation with your cognitive performance. But the amount of sleep hours also has a strong negative correlation with both stress score and work hours. It has a strong positive correlation alongside too with sleep quality score. Now, I mainly wanted to focus on the amount of the negative correlation that sleep hours and work hours have. So I delved deeper into that. I decided, as a default, I wanted to make a histogram of sleep hours. Of course, you can choose anything else, change the number of bins and your color, but I mainly wanted to focus on the histogram. For the Streamlit app, I drew some standard deviation lines and a mean. But here this histogram is showing the most common hours that people sleep at. Some of them, that around 68% of people, sleep between these common hours, which are around 5.25 hours to 7.25 hours. Now, next thing I did was I made a line chart of sleep versus work hours. Now you can see how as the amount of work hours increases, the amount of hours slept decreases. There's a pretty strong negative correlation here that you can see a pretty strong trend. And lastly, I wanted to create a box plot, an age box plot more specifically, because I wanted to know more the kind of age people had in this entire dataset. So most people here have an age between 26 and 42. Now, with all this information, I decided to go even deeper into the sleep hours versus work hours thought I had. So I did a hypothesis and I tested it. My hypothesis was, or the main question I had was, people don't get the correct amount of sleep required because of the amount of work hours that they had that day. Now, the null hypothesis for this was people get the correct amount of sleep, and if they don't, the amount of work hours they have doesn't affect them. Meanwhile, the alternative hypothesis was that the hours someone sleeps is impacted by the amount of hours they work in a day. So for this test, I separated my data into two datasets, high work hours and low work hours, and used Leibniz's variance test to check their variance. Clearly, the variance of the two of them was different, so I used Welch's t-test to account for that. I used an alpha of 0.05 and I got this result, p-value of 0 and t-statistic of -100. I attribute this to having 76,000 rows of data, which of course in a t-test isn't really the best, but that is what the project assignment stated to do, so I went along and I decided to keep the t-test. So based on this information, we can clearly reject the null hypothesis, and so some of the results from this are that the mean sleep of the high work hours is around 5.93 hours, and then the average sleep hours for the people who work less are 6.76 hours. This is a difference of 0.83 hours, almost an entire hour of difference. So, since we rejected the null hypothesis, we can know that the amount of sleep hours someone gets is not by chance, and that the amount of hours someone works does have an effect on it. This means that people who work more can negatively affect the amount of hours slept. So, this gave me some more questions, right? Like, for example, do the hours of sleep you get affect stress? Or maybe they get affected by stress? Does it affect cognitive performance and the quality of sleep? So, of course, that is a hypothesis that I could make for another day, but this machine learning model did help me get a better insights into that. So, just for background information, some of the factors that I used for this machine learning model are, like I said before, sleep hours and work hours. But alongside that, I also used um, stress, cognitive performance, and quality of sleep as some of the factors that went into whether someone rested or didn't rest. Here, these are the default statistics that I used for this test. It's just the basis. I didn't want to change anything, and this is the result that I got. But real quick before I show it, you just know that you can change it if you want to see if you can make the accuracy better or have different results. So here we can see a confusion matrix, which is what I use to see the best version of the results. And we can see how we have more false negative than a false positive, which in my opinion is for the best. Because here what we're doing is we are estimating that more people didn't sleep when in reality they did sleep. No, sorry, the other way around. We are estimating more. Actually, no, I said it correctly. Sorry for the confusion. We are estimating that people didn't sleep when they did sleep, while in comparison, the positive, negative positive, the type 1 error, is basically saying are errors that state that we estimated that they did sleep when they didn't, which is pretty bad if we don't allow, if we estimate that people did sleep when they didn't. People should get their amount of hours slept, as we saw in the hypothesis. So this is the amount of correct predictions, this is the amount of negative predictions, and here I was able to see some of the results. People had the entire machine learning model had an accuracy of 73%, and this is the precision, this is the recall, and this is some of the extra information that I had. But with that, some of the notes I had here are that I could use and implement this model for future hypotheses. And yeah, that is about it for this Streamlit app. Thank you.